Small order of business. Till 2 weeks ago, when tags were running, when tasks were running, they were green. As of Airflow 3.1, now officially blue is the new green. So I should have named my talk "Purple is the New Blue." But for everybody still on Airflow 3 or below, we're going to be talking about how purple is the new green. So I am Ethan. I'm a data engineer at Wix. I've been there for about 5 years. I'm also the company's Airflow tech specialist and evangelist, which means my job is to promote the usage of Airflow and adoption of best practices in the organization. And I've been in the data realm for a bit over 20 years. What we're going to be discussing today, a quick overview of Wix. We're going to discuss what got us looking into deferrable operators to begin with. We'll take a deep dive into deferrable operators, what they are, how they work. Then we'll tell a story of how I went about approaching the problem that we were hoping to solve with deferrable operators, and then pitfalls, lessons learned, and takeaways from the process. So Wix, for those of you who haven't heard of us, we are a website building platform where anybody in the world can build their presence online. With over 200 million users in literally every country in the world, we are the leading software as a service platform. Literally about 4% of every site on the internet is running on Wix. Within our ecosystem, we are dominating with about 40% of the market share for simple website builders. As such, we do have a little bit of data, enough to occupy over 400 people in our data organizations with data engineers, scientists, and analysts. We're ingesting about 20 terabytes of data every day, adding most of that to our data lake, running over 1 million SQL queries on that data every day. In order to do that, we have 3 production Airflow clusters. Right now, we're running our own Airflow 2.6, and we're in the process of migrating to Airflow 3.1 managed by Astronomer. We have over 7,500 active DAGs with over 250,000 daily tasks. And this occupies our workers for over 10,000 hours every day. As such, we came to the point where we wanted to do something about the workload that we were seeing. So why are we here? What brings us here? We saw that our schedulers were reaching their maximal parallelism and our workers were at their peak. And we knew that a lot of the time they were basically waiting for third-party operators to do their thing, whether it's our Trino operators, our Spark, various other types of operators that were just submitting work and waiting for the job to be done. So we hoped to find a way to reduce the bottlenecks of data delivery by shortening the time that Airflow was sitting idly and waiting. We were hoping to reduce the workload in the process, free up resources, and if we can, reducing costs is always a nice bonus, but definitely was not a priority here. So we started looking into how we might do that. Obviously, the first thing you do is throw more hardware at it. Maybe we just, increase our parallelism, add more workers. That would obviously reduce the bottlenecks, but we figured that there were more elegant ways to go about it. We thought to maybe turn some of our operators into sensors where they would just reschedule and then check if the job that they were waiting for was done working. But then at some point, I remembered this is a Jira ticket that we put in our backlog, asking that maybe sometimes somebody look into finding a way to turn some of our heavier hitters into sensors. And then I remembered that a couple of years ago, Airflow came out with a nice new feature called deferrable operators. When it came out, I sent a Slack message to our 100 and some data engineers introducing this feature, letting them know, hey, this is something interesting. We might want to look into this in the future. Please take a look at the documentation. So what are deferrable operators and what is deferral? When we talk about deferring, the word literally has 2 separate meanings. It's either to postpone or pass operation to another time, or to pass the responsibility to somebody else. And that is what we're talking about when we're talking about deferrable operators. Deferrable operators transfer the execution and the supervision of your task from the worker to a trigger service, which is a new service that was introduced in Airflow 2.2. And it does this while whatever external service your worker is working, the worker triggered is still running. The trigger is a standalone process that's part of the Airflow installation. It's capable of handling over 1,000 asynchronous lightweight triggers. We'll take a deeper dive into exactly what triggers are later on. As such, deferrable operators literally free up the worker slot that was running the job until now, making it available to run other processes, increasing the availability of your system. Deferral is defined in the operator itself. Your operator can either be deferrable or not, and whether you choose to invoke the deferrable feature or not is up to you when you instantiate the operator in your task. So let's take a quick look at how execution works in a non-deferrable task. This is the basic architecture of Airflow, Airflow 3 specifically, and what was introduced in Airflow 2.2 was the separate trigger service, which then takes the trigger that we'll see in the later time and interacts with the Airflow database to check its status. A classic operator, as it's running without deferral, would have an execute method where it might make an external call to an external service and basically just wait around doing nothing till the service returns a response, and then your operator returns whatever it gets back, exits, and we're on our way. Alternately, you might have operators that call an external service, get back some sort of ID, and then routinely pull the service waiting to see what the status is, and ultimately when it gets back a status of some sort, exits and returns operation back to the scheduler, where so long as it hasn't, it just waits until it does get, and then try again. In contrast, when we're talking about deferrable operators, what we see is that we might make a call to an external service and get back an ID, or some sort of identifier for the call that we've made. And then what we do is we call the defer method that we inherit from the base operator, and we pass to the defer method a trigger definition, which again we'll take a deeper look at. We implement a trigger that is coupled with our operator, and the trigger needs to get whatever IDs or keys it will require in order to identify the individual instance of our job. And ultimately, it will need to also get a name of another method inside of our operator that it will return execution to once deferral is done. In other words, when the operator will defer operation to the triggerer, it can do whatever polling it needs to do to make sure that the execution is done. And once it is, it'll then call back the operator in this method. So what makes a trigger? Looking at the sample from the Airflow documentation, a trigger literally has a few basic components. It needs to inherit from the base trigger method. It has to have 3 methods built into it. It has an init method, obviously, that defines what keys and parameters it needs to have in order to identify this instance of our method. It needs a serialized method, which then allows it to serialize or read the instance of the trigger from the Airflow metadata database. The serialized method receives a tuple with the class path of the trigger itself and whatever key value pairs or sets of data that you need to identify the individual trigger. And ultimately, it has a run method, which is where the actual magic of the deferral happens, which is where you put your logic of your actual deferral, where you're going to be pulling whatever external service you're going to be running in order to see what its status is. Ultimately, once it's done, your trigger needs to yield a trigger event, and then it returns operation back to the scheduler. So if we look at the classic execution, we have a task that's sitting around and waiting. It's picked up and added to the queue. We have now a worker that's assigned to the task so long as it's running. It might be submitting a job to an external service. The external service is taking its time doing whatever it needs to be doing. Ultimately, it will return a success, hopefully, and your task will be a nice dark green. In contrast, when you defer your operator, again, it's picked up and added to the queue. You assign it to do whatever work you need your external service to do. There is also an instance where you could have your task start directly in the deferred mode, but that's a different discussion. You could then, once you get an ID, have it deferred, and this is where you first see your beautiful deep purple in your Airflow UI. That's where the external process is doing its thing, returning success, and then once it's done, your operator then goes back to the queue, starts running again in the next method that was called, and ultimately is completed. So so now we have an operator that supports deferral. How do you actually get that to work in your DAG itself? This is a sample DAG where we're using my Shiny operator. I have my Shiny operator, and it's running as it typically would. Making it deferrable is literally just a matter of telling it to use the deferrable switch. So now that we understand what deferral is and how it works, let's take a look at how I went about addressing the desire to make our tasks deferrable at Wix. So I started by examining our Airflow metadata database. Again, we have 3 instances. I collected and aggregated the data from all of them. I examined which types of operators we're using and how many tasks we have with each one, how long each one is running. And I looked to identify quick wins. In other words, operators that have a typical long running time and that we have lots of them. So this is just a sample query that I ran against our Airflow database. It gives you the data that you need, and then you could examine that. Again, this is on Airflow 2. On Airflow 3, it's a little more complicated to get this data, but it is still doable. So what did I find? This is a sample of a result of the list of operators that I extracted from my query. We found that we're running over 100 different types of custom operators. We have our Trino operators, our Spark operators, Kubernetes, and Great Expectations. We have data transfer operators from Snowflake to Iceberg to BigQuery. If there's data on it or could be data on it, we have some sort of way of transferring to and from. Obviously, we have our own custom data freshness sensors. We have your Slack operator, your OpsGenie operator, and every type of Python operator that you can imagine. This is what we saw. We saw that between Trino, Spark, and a few others, that covers the bulk of our use cases. So now that we understand what we're dealing with, how you go about addressing it. We could start with Trino, which was about 40% of our workload, or maybe Spark, that's another 20%. But the problem with these custom operators that we have is that they're not simple. We have a lot of logic built into these operators. They're quite complex. Being able to deliver on the promise of making these tasks deferrable would be quite difficult, and there's a high chance of failure. So instead, I went about a different way. I started where it was easy. I decided to start with a minimal viable product, come up with something that works, show the organization deferral is a thing, we could use this, let other people get engaged with it, encourage other people to start making their tasks deferrable, get other people engaged in working on making other operators deferrable, and using whatever momentum we build to build further and further momentum to get everything done. So I decided to use our Great Expectations operator as a proof of concept. Great Expectations, for anybody who's not familiar with it, is a data quality framework that allows you to define a set of tests on a data set, and it runs the quality tests in order to ensure that your data is up to the standards that you define. It allows you to make sure that the data that you put into your data warehouse actually meets the standards that you expect and not get garbage into your data warehouse, for example. The way that our custom Great Expectations operator works, we start by setting a set of expectations or data quality tests per data set. We submit that to our Great Expectations serverless endpoint. We wait a few seconds, and then we pull the endpoint to see if we have results back from the process that needs to run all the tests that we've defined. We check then if we've gotten the results or not. If we haven't, we just wait another 30 seconds, try again. And ultimately, once it has succeeded, we then exit the operator and decide to either end it with success or failure, depending on the quality tests. So now that we understand how deferral works, it's clear that this part of the operator is an ideal sample for deferral. So in order to do that, I took our Great Expectations operator. I examined the execute method in it. I identified what part is actually calling the serverless endpoint in order to get the results, okay? And then basically swap that out and put a trigger in its place. Now, I want to make sure that the operator still supports a non-deferrable mode, which would still be its default at this point. So we have here the section that repeatedly calls the endpoint. So all I had to do was put that in an else condition of whether the operator is currently called in a deferrable state or not. And then if it is deferrable, all I need to do is call a trigger that I haven't yet defined, but that's our next step. So here I'm doing, once again, like we saw in the explanation, I'm calling the defer method, passing a call to the Great Expectations trigger with the identifier of the request that I got from the server and the function or the method that I have in the operator that follows up once it's done. The next step, obviously, is the Great Expectations trigger itself. Literally, these 8 lines of code. It gets the unique identifier from the class itself. It makes a call to the Great Expectations endpoint, and so long as it doesn't have a success key in the JSON that it received, whether the success is true or false doesn't matter right now. So long as we don't have that key itself, we know that the execution has not completed, in which case we asynchronously sleep for a little while and then try again. And so long as this condition is not met, we're going to continue to asynchronously sleep. And once it is completed, only then do we yield our trigger event, returning execution back to the operator. So this is what it looks like in reality. We have the operator being activated. It's green. It sends the list of tests to the endpoint. That's when it was green, and now it's sleeping for 30 seconds. That's when, again, we see our purple in our UI. It's then going to pull the endpoint to see if it got results yet. And once it has, it'll print the results to the log. The task is now scheduled and then completed. And that's really all there is to it. So now that we have a single operator that is deferrable and it's working in our environment and we see that it all works, what's next? So obviously you start by testing it locally, seeing that it works as you expect. You deploy it on a few of your own DAGs, make sure that they work as you expect, monitor the performance of your DAGs, make sure that they are in fact returning the results that you expect, they're working, there's no degradation in their performance. Communicate the feature to your team, get other people involved, like I said earlier, track the adoption of the deferrable option in this operator, and ultimately, once you're done, before that, you want to scale the trigger process itself. You can scale it up, you can scale it out, and you can have more than one trigger service in your Airflow environment. And ultimately, once you're happy with the results, you can set deferral to true by default in your operator so that people don't have to explicitly do it in their tasks. Now, this is the communication that I sent to my team again, explaining to them that our Great Expectations operator now supports deferral. You don't have to read all this, obviously, but this was me introducing our team to the fact that now they could start getting used to seeing purple alongside the green in their Airflow DAGs. In a perfect world, this would be it, but sadly, we do have issues that we've encountered. So when you start working on deferring your operators, make sure that you roll things out gradually. Don't start by deferring everything all at once. Track the trigger process as you go along, making sure that it's not choking, it's not failing. Scale the trigger as you need, as you see fit. Keep track of how many concurrent deferred operators you have running at the same time. You can do that either through the UI or in Airflow2 through the database itself. And whatever you do not start by deferring a single DAG that has 1,000 tasks in it all at once on a weekend. Because if you do, you wind up getting messages in Slack on the weekend at 8 p.m. telling people that the trigger is a little bit flaky and people are concerned, not sure what to do. And then you end up losing a lot of goodwill from the organization when it comes to switching on this new feature. So what's next? We have one deferrable operator. So the next step was going to be to make our Spark operator deferrable, and I'm glad to say that we've got that done. One of the members of our team took that on himself. Once he saw that this thing works and it works well, he sat on it and he made our Spark operators deferrable, which is great. Identify operators that you're using that natively come out of the box with the option to be deferred, such as Amazon and Google. A lot of operators already come with a deferrable option. You just have to switch it on. Next is going to be our Trino operators that inherit from the SQL operator. Right now, that operator is not deferrable. There is some effort on the Airflow open source to make it deferrable, but so long as that doesn't happen, I'm planning on making our Trino operators themselves deferrable. And the real challenge is identifying places where we're using our own custom Python operators and seeing how we can switch those for operators that do support deferral and maybe doing some heavy refactoring to enable this feature. So now that we've set up deferral and we see that it works, what are we expecting to see out of it? So with the three operators that we've spoken about, the Great Expectation operator, the Spark operators, and the Trino operators, between the three of them, they represent about 65% of all of our workload. We said that we have about 10,000 hours a day of worker load, and this represents about 65% of it. Based on the current costs that we have of running our Airflow environments, we're expecting a savings of about $10,000 a month. And that's going to be even greater once we move to Astronomer, where we're literally paying for every minute that a worker is in the air. And a back of the envelope estimate of the environmental impact of having these workers not running comes out to about 10 tons of CO2 per year. So once you activate deferral, while you can expect to see more purple in your Airflow environment, you can expect to see more green in this column and more green in this column. So now that we understand what deferral is, and let's wrap things up. Deferrable operators enable you to improve the execution of your Airflow environment and hopefully also reduce costs. They're actually a lot simpler to do than they seem at first. It seems very daunting going into this operation, and once you understand how it works, and it's really simple, it's really straightforward to get into it. And if you're not doing it yet, you really should. Thank you.